I don't think I want to speak after that introduction. Thank you.
Could you flip the switch for us?
Flip the switch. Which to where?
Down one
Down one.
or up one?
To B? Try that.
That's
There we go. Good. Thank you, Bill. I'm going to talk about the deployment of the DNS security protocol, and this presentation is a combined work from my left, Rob Alstein, Suresh Krishnaswamy, and Russ Mundy, and I are the ones who take the hit for this presentation. It actually represents a somewhat larger effort where the essence of this whole project that we're going to describe here is a community building exercise to try to get everybody moving in the same direction and untangle the problems that occur in the process. So let me walk through the pieces of this. First of all, the view is that there are actually some real threats that DNS security can be helpful in addressing. Here's a handful of them listed. It's possible to get into serious arguments about, are these all the threats? Are these threats real? How many of them are being exploited these days? Such a discussion can go off tracks. Weird versions of it are, how can we stimulate more attacks so that we can demonstrate the necessity of DNS security? I don't want to go there. But there is a bunch of data that says there's spoofing of various sorts of DNS, and there are opportunities to do more violence waiting to happen. DNS security was once upon a time an extremely urgent, immediate problem. There were some demonstrations in the early 90s that led to concern at high levels in the US government, which resulted in very quick action. Vint Cerf called me up urgently one day and said, we've got to fix this, and we started a major project, and that project continued and continued and continued. The specifications have gone through 3 major cycles and are now finally what's the official status? They've made it past last call and have been sent to the RFC editor through the ISG. So that's essentially done except for the publication cycle, which also takes forever. There's been some big strides to make DNS security operationally viable in these iterations. So for example, one of the big changes was the relationship of a parent zone to a child zone, which you'll see in a minute, was too tight before and led to great operational difficulties whenever changes needed to be made. Now that's been set apart enough so that the pieces can be updated more independently. There's been a lot of time spent making these specs more robust, and now a coordinated global effort to grow the deployed base. So we're hopeful, despite some people who looked at this whole process from a distance and say it's taken too long and excuse me, we don't know if it's ever going to happen. We're hopeful that this is actually the time, but it's not going to happen completely on its own. There's too many parts that have to be put together. What does DNSSEC provide? It's a protocol extension to the domain name system protocol that provides for data integrity and origin authentication, and even a authentication of the denial of the existence of certain records. That has some interesting unintended consequences, but it allows the end user or the systems close to the end user to verify that the data, the binding between, principally between a domain name and an IP address, is what was intended by the group or person who created that binding and cannot have been modified in transit or in storage without detection. Certainly modify it, but this provides a way of detecting that that's been changed or that somebody is trying to supply you with incorrect data and spoof you. It fits together with some surrounding protocols. There are, as you will see, we'll have some diagrams, some of the raw data has to be put in the first place, and there are some last mile issues. How do you transfer this information among the parts of the system that are not DNSSEC aware? DNSSEC doesn't intend to provide any confidentiality of the data, and it doesn't actually provide, it's not intended to provide any direct attack against denial of service attacks, direct protection against denial of service attacks. Both of those lead to some fairly intricate and detailed discussions. If we have time, I'll be happy to engage in those discussions. So here's what the end-to-end protection looks like. You have a trusted key. This shows you have a trusted key at the top, and it signs the zone for the top-level domain, and then there is a DS key for signing the key for the next zone, and so forth on down. So you have a hierarchy of keys, and there's actually a pair of keys at each level, one that signs the individual entries within the zone, and one that is signing the key signing key, if you will, for the whole zone. And that double key arrangement is what provides the manageability for making changes within a zone without having that trickle up to the parent zone and cause a tremendous set of changes. Here's what DNS operations look like in an unsigned environment. You have an unsigned child zone and an unsigned parent zone, and blue information, and then the parent zone, whenever there's a change made, reloads the parent zone, and this not very happy child is waiting for the correct information to appear. In DNSSEC operations, things are a bit more complex because keys have to be generated and then used for assigning the elements of the zone, and then that information has to be exchanged, preferably in a secure fashion, else some of the protection provided falls apart, provided to the parent zone, who then signs the that entry in the parent zone pointing to the child zone, and then there is the publication and propagation of that information. What's missing here? And a secure exchange of information. So now going to look briefly at several points of view and see what has to change. So from the registrant's point of view, that's typically an enterprise, what's different? Well, they have to have key generation and key management. They have to engage in their own zone signing operations, and they have to provision the name server. And they have to have a way of securely transmitting the DNSSEC related information to the registrar. And all of that only gets the zone signed and the signatures propagated. But to be really useful, they should actually check signatures from time to time. I'm being somewhat facetious, they should check them all the time. So you have to have validating resolvers that provide security checking, and then every once in a while something goes wrong or there are updates and so forth, so incident handling is required. From the registrar's point of view, that information, you have the complementary side of it. The information has to be received from the registrant and then has to be transmitted into the registry, and of course there will be a need for handling changes and incidents and so forth. From the registry point of view, several things need to be done. Obviously, receiving the information from the registrar, creating the secure delegation in the parent zone, managing the key and key management operations. Every time we talk about key generation and key management, we're talking about public-private key kinds of operations, and protecting the private key is obviously a very strong concern, leading to lots of discussions, some of which are pragmatic and some of which are religious, about what kinds of risks are appropriate or what you do when you're nervous about that. There are some operational issues in that the size of a signed record is substantially larger. We don't have accurate precise measurements, but the numbers range from 3 to 5 times as big depending upon various parameters of the signing, so that each record in the zone is that much bigger, and of course, so that takes up space, and of course, when transmitting that record, that takes up the same additional amount of bandwidth. So this puts some pressure from an operational point of view on capacity, both storage and bandwidth on these name servers. Some question as to how important that is, and it will depend greatly on whether we're talking about relatively small name servers or ones operating at the top end of the spectrum. So that's a discussion for which the people who run .com have very strong feelings of one kind, and people at the other end of the tail may have very different kinds of feelings, for example. And I guess that's just after the zone is signed. There's also the non-trivial question of the computational power required to create the signatures in the first place. Signing operations typically are computationally intensive, and it's not a big deal if you don't have very many, but it is a big deal if you have millions of records to sign. And that leads then to a bifurcation of, well, are we doing this offline, or are we trying to sign things in real time? And obviously it's a lot better if you can get this job done offline and then provision those signed records. But then what do you do when you have to make changes? And then there's a more detailed discussion related to the delivering up authenticated denial of existence of records. So if the query asks for something that's not in the zone, the spec says give back a record that declares authoritatively that entry doesnn exist. And one of the ways to do it, and the sort of expected way to do it, is to deliver up a span, an entry that says everything between alpha and beta, it doesn't exist, assuming that alpha is an entry and beta is the next entry in there. And then that would cover everything that is not that's in that gap, if you will. The problem with that is it enables and very relatively efficient walking of the zone, which raises some privacy problems. And if you follow down that thread, a possible response is, well, let's make up less informative gap entries that are narrower and are computed on the spot for each query, but then that puts a computational load on those name servers because of the cost of the crypto operation. So there's a series of not fully resolved kinds of questions that are still trading off computation versus security and privacy issues in a sort of still bubbling fashion. Tools are all important here. There are some tools that handle generation of keys and that check zones and sign the zones. And there are some authoritative name server implementations, and there are some security-aware recursive name server implementations, but there is not a full suite, fully populated for everybody. So one of the things to track over a period of time, and I would say within a relatively short period of time, talks of coming from us and of this type will start to have inventories and measures of how complete the tool sets are and what's available. Here's a picture of tools that are both present and missing. This is a complete picture, and here's where the tools fit in, all the elements in green. So we have key generation tools, zone signing and checking tools, and the name server serving and checking kinds of tools. There also has to be extensions to the protocol between the registrar and the registry that fit into the EPP protocol. So extensions are being completed to facilitate this. This will serve primarily the GTLD community, which is working with large numbers of registrars. Let's see, there's also some out-of-band tools that are required to move the key set file within the registrant and over to the registrar. More work is going on creating tools and troubleshooting. A substantial amount of work is needed on documentation and training and policy guidance. At the point where an enterprise says, I've heard about this DNS security protocol, what does it do? Somebody has to, there has to be some material available to answer that question. And then the next question that possible adopter is going to ask, okay, so I'm convinced that we're going to need this. How are my people going to implement this? Part of that question is what tools are available, but another part of that is how do my people understand what this is, what's the training, what's the procedures, how do I adopt it into my operation. A whole separate question has to do with a very long adoption cycle. We're in a stage now where there's essentially very close to 0 zones that have been signed. So this is a very easy stage to manage. Nothing's happening. Eventually, there will be a very substantial number of zones that are signed and very common DNSSEC aware resolvers. But in the interim, we're going to have a very clumsy mixture of some zones that are signed and many zones that are unsigned, and some resolvers that are DNSSEC aware and some that are not. What do you do if you make a request for a signed entry and an unsigned entry comes back? Do you trust it anyway? Well, today the answer had better be yes, because that's as good as you're going to get. Down the line, when most things are signed, the answer may be no. A more useful intermediate position is you may have reason to believe that certain zones are signed, and if you get back an unsigned answer, then you should be suspicious of it. Where would such a reason come from? So the notion of trust anchors exist, where there's multiple zones that are signed that are not necessarily connected to parents because the parents are not yet in a position to be signed. And so the tops of each of those islands, if you will, becomes a separate trust anchor. And then that then leads to the operational question of how do you find out what all the useful trust anchors are. This is, in a sense, related to the PGP key signing kind of regimen where you have out-of-band bilateral arrangements or known servers that people can deposit their keys in. Another area where work is underway is to address the so-called zone walking problem, where too much information is exposed about what's in the zone. Once upon a time, it was expected that entire contents of the zone should be public to anybody, anytime, with no restriction. Over the last many years, there's been growing sensitivity toward the disclosure of the entire contents of the zone, even though, quite obviously, each entry is there to be exposed to anybody who asks for it. So it's an aggregation question. As I mentioned earlier, a side effect of the current protocol plus expected implementation is that it makes it easy to walk through a zone and discover each and every entry in a relatively efficient way. And there are now some subsequent investigations as to whether there are ways to thwart that or alternative implementations. There's enterprise-wide experiments underway, trying out the DNSSEC software that is emerging, workshops for operators and others. And it's not quite the case that there are no signed zones. There's a handful, and people are getting some experience with that. I mentioned EPP extensions for DNSSEC, so it allows registrars with different operational models to access the different registries using the same protocol. There's also provisioning work in progress and other experiments. So that's a emerging area to follow. Scott Hollenbeck from VeriSign holds the pen on the spec there and doing quite a bit of work. Here's the locations of some of the registry-level experiments. Netherlands and Sweden are very far out in front on a lot of this work. There is work in Japan. There's a DNSSEC pilot that VeriSign is working on, and there is work on a portion of the trust anchor problem that is being experimented with in a number of settings. Here are some application level experiments that make use of DNSSEC. One of the most often asked questions is, okay, what can I do with this that I couldn't do before? In effect, DNSSEC provides a version of a public key hierarchy without all of the intensity of trying to nail down the identity of individuals, more focused on nailing down, if you will, the identity of the servers and a chain of responsibility for them, and stopping at that point. So that gives you a very light form of a public key infrastructure, which is useful for a broad class of applications, but not everything. That's not it's not going to be sufficient for authenticating an individual user to his bank, for example, but it may be adequate for getting a handle on whether or not it's really your bank or somebody spoofing Citibank or whatever the bank du jour is today for spam. Short list of some of the problems that we're still wrestling with. As I mentioned, privacy, which was not originally a goal. Who signs the root key and what are all the procedures to manage the key at the root? This is not technically a very hard or interesting problem taken by itself. Just the extraordinary level of visibility and multiple agendas that attend to that make that an interesting problem as well. Are there any applications that fit together with DNSSEC so that it would serve as a major accelerator or to propel that into a must-have situation? Possibly. We're still waiting for specifics to emerge. And then I mentioned trust anchors. It's not so bad if you have 1, 2, 3, 10, 20, 50 trust anchors. It gets hard if you have hundreds and thousands of trust anchors, then you have a whole new system. If one examines the sort of the natural arc, we're going to start with a very small number of trust anchors. It's going to grow, and eventually the need for separate trust anchors will disappear as the tree is filled in. And it's that intermediate stage where the tree is not very well filled in, but there's still enough there that we don't know quite how messy all that's going to get. Here's some resources. I think these slides are available online, so there's no need to scribble very hard. And that's the quick tour through the DNSSEC deployment activities today.
We have time for questions.
Well, I get to take a second.
Okay.
Pull up the chair. Any questions? Sam, where are you? I would expect Sam Weiler to stand up here. Since I'm already up here, I can ask some questions. But Spencer, you have this august panel. You can ask, and you don't have to ask Steve. He's already talked a lot.
And I'll ask the august panel. I noticed that we just had the presentation that was talking about larger resource records and the increased incidence of truncation and TCP retrievals, which may succeed or may fail. Where are you guys in thinking that through? Is it a concern?
Yeah, it is. The thing is that there are enough code changes required for DNSSEC anyway, that what we ended up doing was saying you have to support eDNS 0 in order to do DNSSEC. There just is no other way. And there are a couple of reasons for that. The size issue is one of them.
Go ahead, Russ. Jump
Well, yeah, as Rob said, eDNS 0 is really essential for the success of DNS security deployment, because the talk before, it was talking about describing what was happening, falling back to TCP. Frankly, that's just an untenable solution and won't work.
There is one thing to note in that context, though. The way that the protocol works, you don't have to upgrade every stub resolver in the world to start getting the benefits of this. So it's not like you have to have eDNS 0 and all the stub resolvers. It's the protocol from the verifying resolvers, the validating resolvers up to the authoritative name servers where you need eDNS 0. The rest of it, it's optional. It's probably a good idea, but you don't strictly need it.
Thanks, Bill. This is Sam Weiler. I didn't hear a specific list of what you want the people in this room to do. What would you like for them to do, and why is it safe to do that?
Those are two different questions, of course.
Take them in order.
I want, let's see, what do I want the people in this room to do? Learn to spell DNSSEC would be the first thing. More seriously, I think two things. One is focus attention on DNSSEC as if it were real, and think about implementation and what it takes to either do it or to cause the organizations that you're working with to do it. And the other side of that is feedback and participation. Identify what the issues are, whether they're resource issues or technical problems or operational problems or missing tools or missing documents and so forth, and get involved and be vocal about that. So those are the two things to do it. Now, why is it safe? Well, you can trust us. I don't know how to answer that question.
Let me make one additional, hello? Okay. One additional response there, and that is Steve mentioned earlier that this is actually the third basic design of how we're going to do validation of DNS information. And quite frankly, the reason the first two designs weren't, the biggest single reason that they weren't successful, is they did not take enough into consideration what the operational realities were. As we've gone through this particular redesign, there's been a tremendously larger amount of involvement in from the operational community, but we need more. We want to get all the feedback we possibly can. We'd love to have people practice signing some zones right now. We have some experiments ongoing, and anybody that would consider just running a sign zone for a bit, get in touch with any one of us, and we will happily work with additional folks to start actually going through the mechanics of running sign zones so that everybody learns more as we go forward. And one of the important things to do is for us that are trying to get it deployed is to get it worked into your normal workflow, whatever your normal workflow is, and to make it as little disruption as possible. And so to do that, we really want to get additional input from people as to how they actually do go about running their zones today.
Yeah, so start thinking about how you would actually do this in your ops procedures.
Leave the mics on.
So my answer to Sam's question would be, we need to know what the ops procedures are for this stuff, and it's not we sitting up here at the front of the room do, but in order for this to work, the people actually running systems out there need to think through how they're going to use this and tell us whether or not we screwed up. You know, does this fit into your workflow? Can it be made to fit into your workflow? Is there some better way we should have done it? What's the procedure for this? Have you got all the pieces in place to actually securely get the information from here to there? Can you make this follow your existing authentication, your existing authorization paths, where you've already got some kind of a relationship between the customer and the database that the data is going into? Can you make this follow that? All that kind of stuff. It just needs to be thought through. We've done as much as we can, but.
Okay. While Mark is trying to stand up there and ask another question, I would like Michael to come on up and get prepped for your presentation next. Very short questions and even shorter replies, because I do want the last word.
Thank you, Bill. Mark Oster's VeriSign, and this is more of a sort of a plea. We've had, we talked about operations are actually starting to look at DNSSEC and deploying it, and a lot of it's from the registry side, but we've not had a lot of success on doing sort of recursive name server management, and that's where you actually play a big part of, because many of you run some very, very large recursive name server farms, and information coming back from that would be extremely useful.
What he said.
Okay, thank you very much, gentlemen. Further questions, grab any one of them in the halls. One of the things, while he's getting set up, I'm going to use this microphone first.
Let me just move out of the way.
I will use this microphone because you can't hear me otherwise. One of the things that Steve was talking about, DNSSEC and registries and forward stuff, remember that the other side of the DNS is the reverse map. And as ISPs, you have address blocks that you manage. So think about how you would deal with the key management issues and those things for the addresses that you're assigned. So that it may in fact be more applicable than you might have thought in the past. So again, last round of applause for these guys. Get them off the stage.